Hello and welcome back to this ongoing series of tutorials making an asteroids clone in Rust called Rusteroids. This week we're upgrading the heads-up display to show the current level and create a global scope to store the highest score. The first thing to do is check that we have the code from the previous tutorial working. And you should see this, a spaceship flying around with stars on the background. If you don't see this, then use git checkout tutorial 15 to get that code. Links to the repository are in the description of this video. The first thing we're going to do is a very quick job, and that is to show the current level on the heads-up display. For this, we will go to main.rs, and we will scroll to the bottom of our render function where we draw the score. And we'll leave a little comment to show what we're doing. Then we will create a new variable called level of type string, which we will compose from a hard-coded string with toString on and the game data level from the loop we are inside. And after this, we will copy the code from above, which prints the score out, and paste it underneath our new variable. And we will replace the call to the score variable with a call to our new string called level. Then we have to adjust the rect that is being used. We will set the X position to be crate width -110, which will push it to the other side of the screen. Then we should test this new code by running cargo run. And we can now see the level showing in the top right-hand corner. I've sped the next bit up a bit because I'm not very good at the game, despite having played it pretty consistently for 16 weeks. And we see the level does update as we'd expect when we reach level 2. So now we'd like to persist our high score, and we will do that by creating a global scope. Normally in Rust applications this would be highly discouraged because it interferes with multi-threading and parallelism, which is actually one of the things that Specs is doing for us, making sure we don't try to access memory concurrently. However, for some aspects of game development, it's not always possible to avoid global state entirely. This is one such case. So we will go to cargo.toml, and we will add in a dependency of onceCell at version 1.3.1. Then we go back to main.rs and scroll up to the top of the file. And we will add in a reference to use std sync mutex. And underneath this, we will import onceCell sync lazy. Then we will scroll down to where we create the state struct just above the main entry point. And we will create a new struct called GameState with a high score variable of type U32. Underneath this, we will create a static variable called GameState of type lazy mutex GameState, and we initialize this with lazy new. Then an empty set of pipes and mutex new. And inside here, we create an instance of our GameState struct, initializing the high score to 0. And not to forget the semicolon on the end of the call. Then we will scroll up to our drawing code again, underneath where we have just added the code to draw the level number. And we enter a quick comment to demark this next section. Then we take a copy of the score drawing code as we did before, and paste it into this drawing section. And then we will change the name of the variable from score to high score. Then we'll update the text of the variable to reflect this. And we change the hard-coded string to high score. Then above this, we create a new variable called highScoreValue, and the value of this is a reference to the GameState static variable calling .lock, then .unwrap, and finally the highScore variable inside. We update the string builder below to reference the new highScoreValue variable. Then we update the Y position of the rect new to be the game height -60. Which is the height of the rect with an extra 10 as a margin. We run cargo run again, and we can now see the high score variable in the bottom left corner. Of course, it won't change yet because we haven't put in the code to do that. To add this in, we will first navigate to missile.rs, and then we scroll down to where we update the GameData.score. We will create a new variable here called GameState, referencing crate GameState.lock.unwrap. Then we will check if the game data score is higher than the game state high score. and if it is, we will set the new game state high score to be the same as the game data score. We execute cargo run again. We see that as we score points, the high score changes to reflect the new highest score that has been reached. We will then deliberately die to test that the high score is preserved. And after we die, we can see that it is indeed preserved, and not until the current score is greater than the high score do we start to update the new high score. And that's it for this week. We now have a mechanism for preserving persistent global game state. We will probably be adding to this in later weeks. Join us next week, where we will further improve on the graphical experience by wrapping around the player more effectively. If you have any questions or comments, please leave them down below. Don't forget to subscribe to the channel and turn on notifications to be notified when the next video is up. For now though, I'll wish you a good day and hope to see you again soon. Bye for now.